Hello students, in previous lecture we have studied detail about the isomerism, that is structural isomerism in coordinate compounds. See here, isomerism shown by the coordinate compounds are of two types. That is first structural isomerism of coordinate compounds. It is of again four types. That is linkage isomer, ionization isomer, hydrate isomer, or it is also known as solvate isomer, and it is coordinate isomer. There are four subtypes of structural isomerism shown by the coordinate compounds. All of you studied in structural isomerism the coordinate compounds which having same molecular formula, but there is difference in the linkage of ligands or groups to the central metal ion. According to that difference in the linkage of ligands or groups to the central metal ion, these are classified into four categories, and all of you studied about that in previous lecture. Today we are going to study about the stereoisomerism, which is shown or exhibited by coordinate compounds. Then see here, what is stereoisomerism? Stereoisomerism, it is nothing but these are the isomers which having the same molecular formula, and these coordinate compounds, these isomers also have the same structure, but there is a difference in their configuration of central metal ion. That means stereoisomerism shown by the coordinate compounds is of again in two different types. That means there are two subtypes of stereoisomerism of coordinate compounds. First one, that is geometrical isomerism. Geometrical isomerism, or it is also known as cis-trans isomerism. Cis-trans isomerism. All of you studied about the cis-trans isomerism or geometrical isomerism exhibited by the different types of organic compounds. But2-ene compound shows cis-trans type of isomerism. All of you studied about that. Cis-but2-ene and trans-but2-ene, in which same groups when lies on the same side of carbon-carbon double bond, then it is a cis isomer, and same group when lies on the opposite side of carbon-carbon double bond, then it is a trans-but2-ene in trans isomer. All of you studied about that. Then we are going to study about the geometrical isomerism, that is cis-trans isomerism shown or exhibited by the coordinate compound. Then see here, first of all we have to discussing on what is cis isomerism or cis isomers. See here, cis isomerism of coordinate compound in which identical groups or same groups, group means here ligands, that is same ligands or identical ligands when lies on the adjacent side or same side of central metal ion, then it is a cis isomerism. That means same ligands when lies on adjacent side of central metal ion, then it is a cis isomerism. And what is trans isomerism? Trans isomerism is nothing but it is a when same ligands in the coordinate compound, these lies on opposite side of, that is opposite side of central metal ion in the coordinate compound, then it is a trans isomerism or trans isomers. Then we are going to discussing about the cis trans isomerism in different type of coordinate compounds. Then first of all, see here, coordinate compounds are of different types. That means coordinate compounds which having coordination number 4, that which shows and which having the tetrahedral geometry, or it may be square planar geometry. Now we are going to discussing on the cis trans isomerism of coordinate compound which having coordination number 4 and having tetrahedral geometry or square planar geometry. Then see here, the geometrical isomerism in coordinate compounds. In coordinate compounds having coordination number 4, and there are two types of coordinate compounds which having coordination number 4, that is tetrahedral coordinate compounds. Tetrahedral coordinate compounds. See here, coordinate compound which having tetrahedral geometry. These type of coordinate compound does not shows or exhibits cis trans isomerism. Then see here, the second one type, that is geometrical isomerism in coordinate compound which having square planar geometry. Square planar geometry of coordinate compounds. In coordinate compounds, then these are type of coordinate compounds which shows geometrical isomerism. Then see here, we will discussing on this by taking examples of different types of coordinate compounds. The geometrical isomerism of coordinate compound in square planar geometry which having, first of all we will discussing on the coordinate compound which having molecular formula, that is Ma2B2 type complex. See here, the molecular formula of coordinate compound, if it is of Ma2B2 type, that means M is a central metal ion or atom, A, capital A and capital B, these are nothing but these are monodentate ligands. Monodentate ligands. See here, Ma2B2 type plus minus N, that type of coordinate compound which having geometry square planar. These shows cis trans isomerism. For example, cisplatin, all of you studied about that. Cisplatin is a drug or medicine which is used in the diagnosis and treatment of cancer, which having formula, that is PT NH3 twice Cl2. See here, it is of Ma2B2 plus minus N type of complex. Then in this complex, PT2 plus ion is at the center. That means it is a central metal ion. PT2 plus is a central metal ion which is surrounded by 4 ligands. That is 2 NH3 groups are there. 2 NH3 group and 2 chloro groups are there. It is 2 chloro groups are there. See here, it is a square planar geometry, which having square planar geometry. Then see here, two NH3 groups, same groups, lies on the same side of, or lies at the adjacent side of central metal ion, that is Pt2 plus n, or considering chloro groups, that is two chloro groups, that is identical groups, ligands, lies on the same side of, adjacent side of Pt2 plus ion. Then it is a cis isomer. That means it is a cis isomer of this complex. Then when same groups, that is either chloro group or amine group, when lies on the opposite side of central metal ion, then considering chloro group, if chloro group lies at opposite side of central metal ion, that is Pt2 plus, then it is a, and NH3 groups which are also at opposite side of Pt2 plus ion, then it is a trans isomer of this complex. Then see here, cisplatin, that complex is of Ma2B2 type complex ion or complex, which shows two different types of, that is cis and trans isomer, that is geometrical isomers. Then one more example or geometrical isomerism shown by the one more type of coordinate compound which having geometry square planar, that is second one, that is Ma2BC plus minus n type of complex. See here, there are three different types of ligands are there, that is A, B and C are nothing but these are monodentate ligand, in which there are two ligands are identical and remaining ligands are different type, which having molecular formula Ma2BC plus minus n type of complex. Then example of this type of complex, that is see here, CO or the same Pt NH3 twice Cl Br, that is the example, one of the example of this type of complex having square planar geometry. Then see here, different types of ligands are there, NH3 amine ligands, Cl chloro and Br, that are bromo. Three different types of ligands are there, but here to draw the cis isomer and trans isomer of this complex, we have to consider the NH3 groups, that is here two identical same NH3 groups are there, when these lies on the either side, same side, adjacent side of Pt2 plus, then it is a cis isomer, and remaining two ligands, that is Cl minus and Br minus, these are on either, lies on either side of NH3 ligands. Then see here, it is a cis isomer, and in trans isomer, same identical NH3 ligands lies on the opposite side of Pt2 plus ion, and where the remaining ligands, that is Cl minus and Br minus, occupies the remaining space around the central metal ion, that is Pt2 plus. Then it is a trans isomer of this type of complex. Then see here, cis isomers are more soluble than the trans isomer in aqueous medium, and cis isomers are more reactive than the trans isomers, as well as these cis isomers have non-zero dipole moment. That means this shows the dipole moment, non-zero dipole moment. That means they have the value of magnetic moment, and in trans isomer these have zero dipole moment. That means they does not show the dipole moment, which having the value of mu, that is 0. Then that is about the cis trans isomer of Ma2Bc type of complex. Then geometrical isomerism, which is shown by the coordinate compounds. Coordinate compounds which having coordination number 6 and which having geometry, that is octahedral geometry. Octahedral geometry. See here, the coordinate compound which having coordination number 6 and having octahedral geometry, these type of coordinate compound shows geometrical isomerism, that is cis trans type of isomerism. Then see here, first type of this type of coordinate compound of Ma4B2 type of complex. See here, Ma4B2 type of complex or coordinate compound shows geometrical isomerism, that is cis trans isomerism. For example, CO, NH3, 4, Cl2 plus is the one of the example of Ma4B2 plus minus N type of coordinate compound which having octahedral geometry. Then see here, the cis isomer of this type of complex is the central metal ion, that is CO3 plus. CO3 plus is a central metal ion which is surrounded by 4 NH3 groups and 2 chloro groups. Then CO3 plus ion at center, which is surrounded by 2 Cl, that is chloro group, which is present at first and second position, that is at adjacent position of CO3 plus ion, and remaining 4 NH3 groups or ligands are present at the remaining position of the coordinate compound. Then see here, that is the first position, second one, third position, fourth position of ligand, fifth position, and it is the sixth position. Then see here, chloro groups, these are lies, that is identical groups lies at the adjacent side of CO3 plus ion. Then it is a cis isomer. It is a cis isomer, and when the chloro group when lies on opposite side, that means these are lies at, or these are present at first and sixth position, then these are the trans isomer, and the remaining 4 NH3 groups are present at the remaining position of this complex or coordinate compound. In this example, same or identical group, that is chloro group, lies at first and sixth position. Then it is a trans isomer of this type of complex. Then one more type, that is A4BC plus minus N type of complex. Example of this type of complex is Cr NH3 4 Cl Br type complex, that is plus. Then see here, in this complex Cr3 plus central metal ion, which is surrounded by 4 NH3 groups and 2 different types of, that is chloro and bromo groups are present here. And see here, when Cl minus, that is chloro group, and bromo group, which is at adjacent side of Cr plus 3 metal ion, and remaining position NH3 groups are there, then it is a cis isomer of this type of complex. See here, Br minus and Cl minus, chloro and bromo group, lies at adjacent side of Cr3 plus ion, then it is a cis isomer. And if chloro group and bromo group, when lies at first and sixth position, that is opposite side of Cr plus 3 central metal ion, then it is a trans isomer or trans isomerism of this coordinate compound, which having octahedral geometry. See here, Br minus and Cl minus is present at first and second position, and here chloro and bromo groups lies at first and sixth position. Then these are the cis trans isomerism of A4BC plus minus N type of complexes. Then one more example or type of coordinate compound which shows geometrical isomerism, that is cis trans isomerism. Third one example, that is AA2B2 type of complex plus minus N. See here, example of this type of complex, that is CO En2 Cl2 plus 3 C plus 1. See here, the cis isomer of this complex, in which central CO3 plus ion, which is surrounded by 2 bidentate ligands and 2 monodentate ligands. Then here, that complex which having octahedral geometry, in which 2 chloro groups which are at adjacent side, that is first and second position, and remaining bidentate ligand, that is ethylene diamine, which is at this position, which having octahedral geometry, that is the cis isomer of this complex. And if chloro group, which lies on the opposite side, that means at first and sixth position, first and sixth position of central metal ion, and the remaining two bidentate ligands which is present on the remaining position of this complex of central metal ion in this complex, then it is a trans isomer of this complex ion or coordinate compound. Then see here, these are the geometrical isomerism shown by the coordinate compound which having coordination number 4, which having square planar geometry, and the isomerism, geometrical isomerism shown by the coordinate compounds which having coordination number 6 and having octahedral geometry. Then the second type of stereoisomerism shown by the coordinate compound, that is of optical isomerism. Optical isomerism, these are nothing but non-superimposable mirror images of each other. Optical isomerisms are also known as enantiomers. Optical isomerism, or these are also known as enantiomers. Then enantiomers which are non-superimposable mirror images. Mirror images. Then see here, the H having mirror image like this, and that is superimposable mirror image. See here, like this, it is a superimposable mirror image. H having superimposable mirror image, but the B structure which having the mirror image like this, and which are non-superimposable mirror image like this. That means they cannot match to each other, or they cannot match exactly with each other. That is non-superimposable mirror images. That B has non-superimposable mirror image like this. All of you studied about the enantiomers or optical isomers, which is exhibited by the alkyl halides or monohalo compounds. Then optical isomerism or enantiomers shown by the coordinate compounds that we have to discuss here. Then enantiomers, these are of two types, that is D form and L form of enantiomers. See here, there are two optical isomers, that is these are mirror images. One of them is, if it is D form, then another isomer is of L form. Then what is D form? D form means it is a dextro-rotatory substance, and L form that is leo-rotatory substance. That means one of the isomer of that optical isomer is D form while another isomer is of L form. D form enantiomer which rotates PPL to the right hand side when PPL passing through the solution of it. That means the solution of that substance which rotates PPL to the right hand side, then it is a dextrorotatory substance, and the substance which rotate PPL to the left hand side when PPL passing through it, then it is a L form of or leo-rotatory substance. Then in optical isomerism or enantiomer, there are D and L form of mirror images. That means these substances are of optical active substances. Then optical isomerism in coordinate compound, we have to discussing. Now we are going to discussing on the optical isomerism shown by the coordinate compound. Then the optical isomerism shown by coordinate compound which having coordination number 4, and if the coordination number 4, there are two different types of coordinate compounds are there which having tetrahedral geometry as well as square planar geometry. Square planar geometry. That means coordinate compound which having coordination number 4 having tetrahedral geometry. These type of coordinate compound does not shows optical isomers because of their labile nature. That means their falsy nature. They cannot shows the optical isomerism. And the coordinate compound which having coordination number 4 and having square planar geometry, this type of coordinate compounds also does not shows the optical isomerism or enantiomers. It is due to their axis of symmetry. That means in square planar geometry, central metal ion which is surrounded by ligands in same plane and which having axis of symmetry. Because of axis of symmetry, that does not shows the enantiomers or optical isomerism. Then optical isomerism shown by the coordinate compound which having coordination number 6 and having octahedral geometry. Then see here, there is one of the type of complex, that is MAA3 plus minus N type of complex which having coordination number 6 and having geometry octahedral geometry, in which AA type ligands are there. That means AA type ligand means it is a bidentate ligands. Bidentate ligands. Then example of this type of complex, that is CO En3 plus 3 complex, in which CO3 plus ion is at center, which is surrounded by 3 bidentate ligand, that is 3 ethylene diamine ligands which are that is 3 identical bidentate ligands which having geometry octahedral. That means see here, ethylene diamine, these 3 ligands which is at this position. Therefore we can draw the enantiomers, that is D form of, it is a D form of enantiomer shown by this coordinate compound. See here, 3 ethylene diamine, that is bidentate ligands which surrounds to the CO3 plus ion and which having octahedral geometry. See here, that is having octahedral geometry. And the mirror image, that means L form of this coordinate compound is shown like this or drawn like this, CO3 plus ion which is at center and which is surrounded by 3 identical bidentate ligand, that is ethylene diamine, then En, ethylene diamine, and third one that is at this position. Then see here, that is the L form of enantiomer or optical isomer shown by this type of complex or coordinate compound. See here, that is about the optical isomerism shown by the coordinate compound which having octahedral geometry in MAA3 plus minus N type of ligand, and this type of isomerism cannot shown by the coordinate compound which having tetrahedral geometry or it is square planar geometry. That is about the optical isomerism shown by the coordinate compounds. Then isomerism, that is stereoisomerism, exhibited by the coordinate compound in different types of coordinate compound. All of you studied about that. Then in next lecture we have to discussing about the VBT theory, that is valence bond theory of formation of coordinate compound, and the compound formation according to the VBT theory we will discussing on that point in next lecture. Thank you.